All right, today's advantage goes to our geo students, okay? Today's advantage goes to our geo students, and here's why. If you go back to last year and you think of the unit on transformations, okay? Now, non-geo students have still heard these phrases before, okay? If I take a triangle, I can transform it by shifting it left or right. I could shift it up or down, and in geometry, when we take something and we shift it around like this, what's that called? Translation. So in geometry, a translation is to take an object and shift it around the plane. Okay? I could also take that object and I could reflect it, right? Okay, so I can reflect it this way, I can reflect it that way, I can reflect it a number of other ways. I could also rotate it, right? I could also rotate it. And we gave a phrase in geometry to all those things. Rigid motions. Rigid motions, right? Rigid motions are when we move an object around and it stays the same size and shape. Okay? A good example of that would be when you grab an icon on the computer and you just slide it around, right? But then if I was to take that icon and flip it over, still the same size and shape, it's just flipped, right? Or rotate it, right? But when you take your fingers on your phone and you do one of these, you're zooming in or zooming out, right? The object now changes what? Size or shape, right? Which is no longer rigid motion, right? So rigid motion is when you move it around and it stays the same size and shape, right? A non-rigid motion is that dilation, okay? So what we're going to do today is we're going to talk about a rigid motion where we take a function and we slide it around the plane, okay? So we're going to translate a function around the coordinate plane, okay? And it looks like we got these complex equations. It's like Picard. Now you got equations with absolute values in them and numbers outside of them, and it seems awfully complex, right? But it's not. It is not. So what I want to do is use this example here to sort of teach you the whole lesson. Okay, you're going to learn everything in like literally one example for this lesson. Okay, so what I'm going to do first is I want to graph this. Okay, I want to graph the absolute value of x. What is the absolute value of x? Well, it's a graph that looks like what kind of letter? What does an absolute value graph look like? A V. Yeah, it's one of those, right? So if I was to create a really quick, crude t-chart, I would have x and the absolute value of x, right? And so if I just picked 5 values, there's 5 values, right? And I said, guys, what's the absolute value of -2? 2. -1, 1. 0, 1, and 2. All right, so if I plotted those points, guys, what you'd get is a picture that looks like this. And your V takes shape, right? So it looks like one of these. Absolute value of x. Now, Zach, here's what I want to do to it, right? I now want to take this absolute value and I want to add a couple of numbers. I want to add a number inside, well, subtract a number in here, add a number here. I'm just going to create another t-chart to do this, okay? So boom, there's our function. Here's our t-chart. Now, do you agree on your t-chart on your calculator? You can pick your values of x rather easily by just toggling up and down. All right. So I'm going to toggle for you. All right. We're going to look at these values: 0, 1, 2, 3, and 4. All right. Ready? Plug in 0. 0 minus 3. Negative 3. The absolute value of negative 3. 3. 3 plus 2. 1 minus 3. Absolute value. Plus 2. 2 minus 3. Absolute value. 1 plus 2. 3 minus 3. 0. Absolute value. Plus 2. 4 minus 3. 1. Absolute value. 1. 1 plus 2. All right, so I got enough points. So if we were to plot these 5 points, we would have 1 here. All right, so there's our points, and I think you can see what the shape is going to take. It's going to take on this shape. Boom. Boom. And that was the absolute value of x minus 3 plus 2. Ariel, if you look at this red graph, okay, can you agree that it's the same size? Well, okay, I'm going to use the word size loosely. Do you agree that the V is opened up the same amount in both? So they have relatively the same shape. Would that be fair to say? Okay. So Ariel, would you agree that to get this red graph onto this blue graph, I would have to do some shifting? What would you suggest it would take for me to take this red graph and get it on the blue graph? All right, so Ariel says that to go from here to here, I shifted it to the right 3 and up 2. Can we all agree that that looks correct? All right, let's write that down for a minute. All right, so Ariel said that this goes right 3 and up 2. Okay? I want you guys in your head, and I need everybody to do it. In your head, okay? We're not doing this verbally. I want you to look at this equation. I want you to look at what we did, and I want you to come up with a hypothesis as to how this and this can be created without creating a t-chart. All right? So can I figure out what to do by looking at this without creating our t-chart? All right? So if you think you have an idea, keep it in your head for a minute. Let's do another t-chart with this example here, and let's see if your thought works. Everybody got an idea in their head? Let's see if it works. All right, so we're going to do another t-chart with that. And again, because I'm a math teacher, I kind of know what is going to happen here. I'm going to use these values. All right, negative 3 plus 1. Absolute value. 2 minus 4. Negative 2 plus 1. Absolute value. 1 minus 4. All right, and I will save you the time. That's negative 4. That's negative 3. And that's negative 2. And so if I plot those 5 points, and there's my new graph. Ryan, if you look at my green graph, right? How did I get from my red graph to my green graph? I went down 4 and left 1. All right, so I'm going to do that as left 1, down 4. Left 1, down 4. Okay. Did your hypothesis come true? Is what you thought going to happen, happen? Yeah, right? And so the hypothesis that you probably had was, okay, well, this is x minus 3. I had to go right 3, so it looks like I do the opposite of what this says. This says plus 2, I went up 2, so this looks like I do exactly what that does say. So for this one, it looks like, it looks like I do the opposite of this, so I go left 1 and minus 4, down 4, and that's exactly what we did. So what's our rule? We do the opposite of what's in here, and we do exactly what this says. This is left and right. This is up and down. Okay? And you see it happen, right? So based on that idea, guys, what do we think is going to happen here? Thank you. What do we think is going to happen here? It looks like I'm going to shift to the right 6 and down 8. Exactly. So it's always going to be the opposite, left and right, and the actual up and down. The opposite, left and right, the actual up and down. So this is going to go right 6 and down 8. Now I should add one word to both of those. What is that word? What? The word shift, right? Because that's what I'm actually doing. So I want to make sure I say I'm going to shift right 6 and I'm going to shift down 8. Cool? So I literally taught you guys everything you need to know right here, okay? So, again, multiple representations means giving you problems that are asking you to do the same concept in different ways. So here's a multiple representation. Here I give you a graph. I don't give you a function. And what do I want to do? Well, this is a graph of f of x. So let's label it. A second function is defined by this. Now, I agree that this looks very different from an absolute value graph that we just did, right? But Dylan, if we use the exact same concept, what do you think we need to do based on the way this is written? I could plug it in, but let's make it even easier. I don't want to do any work. Based on that last example, what do you think I need to do to this graph? Shift it. Shift it how? Shift it to the right 3 and shift it up 1. Fair to say? Yeah. And so what do I really have on this, guys? I have a point here that I can move, and I have a point here, and I have a point here, and I have a point here. There's 4 points that make up that graph, and then I can just play connect the dots, right? But all I want to do is take those 4 points and shift them to the right 3 and up 1. There's those 4 points after they've been shifted. And then just play connect the dots. And that is my graph of g of x. Now, Dylan, here's the thing, right? Going back to what you just said. You said something about plugging it in, right? Do you guys agree that I have a graph of g up here now, right? So this question right here says, what is the value of g of 0? Well, okay, let's just go to my graph. Isn't that the point 0, 2? So on my shifted graph, I know that the answer is that g of 0 is 2. Now, what if I did it, guys, using what Dylan was just saying? Dylan was saying, well, plug it in. Well, this is my function, right? So what if we did what Dylan said? Let's plug it in. Let's plug 0 in. G of 0 is that. What's 0 minus 3? Negative 3, right? So this would be the same as f of negative 3 plus 1. Well, do we have a graph for f? Yeah, what's f of negative 3? Well, negative 3 puts me here at, negative 3 what? Negative 3, 1. So what is f of negative 3? Hello? F of negative 3 is 1, right? So what's 1 plus 1? 2. So Dylan's idea of plugging it in wasn't necessarily a bad idea to answer that part. Okay? Identify how the graph has been transformed and produce the sketch. All right, we already did it. We already did that, okay? Guys, this seems like a really difficult problem. Okay? And in fact, you know, Abby's like practically cowering right now. Look at her. She's like, it's not that bad of a problem, right? It says that a function f has a domain of that and a range of that. What are the domain and range of this? Okay, so clearly it's going to be talking about some shifting, right? So Abby, since I know you're not afraid, based on our conversation, how would that function shift? Down 10 and left 7. So I'm going to go left 7. And did you say down 10? Oh, you said up 10, right? Good, thank you. Up 10. Left 7, up 10. Very good. Left 7, up 10. So guys, check it out. Domain always means what? How far can I go to the left? How far can I go to the right? So this domain, check me out, ready? This domain starts at -3 and goes to 10. What, I'm sorry, I said that the wrong way. Oh yeah, it does, domain, right here, this one. Okay, this domain starts at -3, goes till 10, right? What am I gonna do to this graph? I'm gonna shift it to the left 7. So don't both of these things do that. So didn't I just literally take -3 and 10 and subtract 7 from both of those to do that? That makes sense? Okay. And then my range is y is less than or equal to 22. Range means what? Up and down, correct? So I want to be less than or equal to 22. So if this is 22, that means my whole graph is down here, right? But what do I want to do to this graph? I want to shift it up 10. So the highest point is no longer 22, it's now 32. So all I'm going to do is this, guys. I'm going to take my domain of -3, x, and 10, and because I'm going left 7, I'm going to subtract 7 from both of those, which means that my domain is now -10 to 3. My range which was this, now I'm going up 10, which means the y values are going to increase by 10. And there's your new domain and range. All right, guys, this seems like a lot of work here to finish up. We're going to cruise now. We're going to cruise. New phrase, Leonardo. The new phrase, parent function. Parent, in this case, it's the parent quadratic, okay? Guys, if I just say y equals x squared, and I asked you guys to graph y equals x squared, it would be a parabola, right? And it would be a parabola with these values, okay? So if I was to sketch that, it would look like this. Guys, key concept of the day, ready? Key concept of the day. Those transformations that we talked about, they work for pretty much all functions. Not just an absolute value, but also something like this. So what would you suggest? That this is a parabola that started off like this, that's been shifted to the right 4 and down 5. correct? So if I was to take this parabola, let's sketch it, shift it to the right 4 and down 5. And there's my graph. Guys, all points move the same amount, right? Can we agree with that, Spencer, that all the points are going to move the same amount? So where does the vertex now lie in my red graph? Well, it started at 0, 0. I shifted it to the right 4 and down 5. So where did it go? 4, -5. Yeah. So my turning point shifted from 0, 0 to add 4 and subtract 5. So now it's at 4, -5. New word. Not new word, guys. Word that you've seen before. Word we haven't talked about in a long time, though. Okay? Word we haven't talked about in a long time. Increasing. Increasing is the idea of being on the roller coaster, right? So if I get on the red roller coaster and I'm riding it from left to right, am I increasing right here? No, I'm what? I'm going down until I get to the very bottom, and then I start to increase. Now there's an arrow on this, meaning it's going to increase forever. Where does it begin increasing? It begins increasing here at what x value? 4. So it starts increasing at 4 until, does it ever stop? No. Is it increasing at 4? No, because at the bottom of the hill, you're not increasing, right? So the domain interval where this is increasing is everywhere from 4 to infinity. Haven't seen that used in a little while. So we said that on f of x, the vertex was this. What's the minimum value, guys? What's the minimum value of my red graph? What? Yeah. So what point? What's the minimum value though? Is it the 4 or is it the -5? The -5, right? Yeah. Oops. Sorry. Okay. So I got that. Last piece of this question. There's a new function, g of x. G of x is right here. Right? What's the vertex of that one? 6, -10. So what's the minimum value of that one? Which one of those has a lower value? The g of x. All right, last problem of the day. Last problem of the day. This is a graph of f of x. What am I going to do to f of x? Well, I'm going to create a new graph by doing what to this one? Shifting it right 2. Is it going to go up and down at all? No, all it's going to do is shift to the right 2. So this point, and that point become this one, and that one. Show that those are the zeros of g of x. Well, guys, where does g of x cross the x-axis? At -1 and at 2. Shown, right? There it is. It's graphically shown. Guys, these are not trick questions. These are easy questions. My new function. What is the value of my new function at -3? Well, on the red function at -3, I'm at -1, 2, 3, 4. I'm at -6. And on my new function at 0, I'm at 3. And on my new function at 4, I'm at -3. There you have it. There you have it. Okay. You guys got a homework assignment? Get started on it. Again, this homework assignment right now and the one that we're going to do tomorrow is due on Monday.